Are you ready for a proof? I think this is the way to do proofs. Okay, so for today's proof, we have got this theorem. And what our theorem says is that if we've got this point here, this kind of common point, the same point, and we draw a tangent to the circle at A and a tangent to the circle at B, those two lines or line segments are equal in length. Okay, so the essence of our proof to do that is that we are going to construct two triangles. So our two triangles, we're going to construct these radii, and we're going to construct this line in between OP, and then we're going to show that they're congruent. And if they're congruent, it means that each corresponding side is equal. So yellow is equal to yellow, purple, purple, and our original greens that we looked at, well, those must be equal to each other. And just to kind of see how we're going to do our case of congruency, well, we've got a tangent and a radius, and we know that tan rad is 90 degrees. So given that we know that, we can show these two are congruent triangles. Okay, because of right angle hypotenuse side. So we're going to use RHS for our congruency. Okay, well, I was going to put that in brackets. So that's going to be our reason for congruency. So now all that remains is let's fill in those gaps of how we're going to show that congruency. So first off, we're going to construct these radii. And our radii are OA and OB. And what else do we construct? We constructed or drew this line OP. Then to show our congruency, we have got in triangle something or other and triangle something other else. We're going to show three things. For each of those things, we are going to give a reason, and we're going to sum up by saying, therefore, somebody's in the way, and you can go in the way on the other side. And so, therefore, that triangle is congruent to that triangle, and we already know that we're kind of going to push for right angle hypotenuse side. And once we've shown congruency, therefore, we're going to say, okay, well, cool. PA equals PB because those two triangles are congruent. Okay, so there's kind of the overall structure. So some more details. Well, we've got OAP, OAP, and OBP. Order doesn't matter up at the top, but I figure if you can get it right up here, why not get it right? And down here we've got OAP, we're going to show as congruent to OBP. Okay, so doesn't matter what order these reasons go in, one doesn't rely on the previous one. So I'm going to start with OA equals OB. I'm going to put the left-hand triangle stuff on the left and the right-hand triangle stuff on the right, the other right. And those two are equal because they radii. Then we know that, I don't know, this line here, OP is common. So OP is common or OP equals OP. Doesn't matter which kind of version you write it in. Common is kind of our keyword. And finally, we've got that angle and that angle are 90 degrees. Now, I'm just going to call that A1 and I'm going to call that B1 so that it's easier to write over here. B1, and the key bit is that we know they're equal because they're 90, so we're doubling up our reason, which is tan rad. And yeah, then we've got that, and yeah, that's the last bit because we know therefore that PA equals PB because those two triangles are congruent.
And make it maths.